Okay, last time we talked about the atom, and we talked about neutral atoms when the number of protons is equal to the number of electrons. So what we'll do today is we're going to talk about ions. And ions are when an atom does not have the same number of protons and neutrons. And I have a list here, and these are all, you notice they all have these positive symbols. And these are all elements that have actually lost electrons. So, really briefly, an ion is when the number of protons is not equal to the number of electrons. So if an ion is positive, like you're seeing below, that means it actually has lost electrons. And how many it lost depends on the number. So if you just see this symbol, that means it lost 1. If you see this symbol, that means it lost 2. If you see this, that means it lost 3. If you see this, that means it lost 4. If you see this, that means it actually gained electrons. So if it's negative, that means it gained 1. If it's 2 negative, that means it gained 2. If it's 3 negative, that means it gained 3. If it's 4 negative, that means it gained 4. So the examples below are all positive ions. So for example here, this is an aluminum atom that lost 3 electrons. And this is a calcium atom that lost 2 electrons. This lost 1 electron. Now, here you'll notice that there's multiple possibilities. These 3 on the right here are examples of things called transition metals. So these are transition metals. And some transition metals have more than one charge. So when you look at your periodic table, certain elements will only have one charge. They'll either be positive or negative. And the ones that are positive are metals. That means metals lose electrons. But some metals have more than one possibility. And with that, we have to use a Roman numeral system. So, for instance, if it's an element that loses 1 electron, we use the Roman numeral 1 to indicate that it lost 1 electron. If it lost 2, then we use the Roman numeral 2 to signify a loss of 2 electrons. 3 would indicate it lost, indicate that it lost 3 electrons. And then if it's a 4, that means it lost 4 electrons. So let's take a look at some of the elements that gain electrons. So for instance, oxygen. Oxygen is the 8th element, has a mass number of 16, and it typically likes to gain 2 electrons. Chlorine is the 17th element, has a mass number of 35. It typically likes to gain 1 electron. And nitrogen typically wants to gain 3 electrons, and it's the 7th element. Now, when you know the charge of each element, or what they would like to do, how many electrons they would like to gain or lose, then you can easily derive the formula of these compounds when you put them together. So, for example, if I was to take something like potassium and something like chlorine. Now, knowing that potassium wants to be positively charged, and again, you don't have to know this, you don't have to memorize this. You'll be provided a table, and you'll have the charges. You just have to look at the table. So the periodic table says that potassium wants to be positively charged, and chlorine wants to be negatively charged. And each one wants one either to lose an electron, as in potassium's case, or to gain an electron, as in chlorine's case. So we use something called the crossover rule. Okay? And this is a rule that predicts the formula of an ionic compound. And again, an ionic compound is between a metal, which are things that lose electrons, and a nonmetal. The nonmetals are on the right side of the periodic table. So the crossover rule uses the charge and the number to predict the formula. So all you do is you take the number and you put it to the other side. So this would be K1Cl1, but you don't write the ones. So this ends up being just simply KCl. Now, what's it called? Okay, so there's a naming system. The metal's name doesn't change, but the non-metal's name does change. So this would be potassium chloride. So what happens is the element that gains electrons changes its last name to an IDE ending. That's something you just have to get used to. So let's take a look at another example. Let's take a look at sulfur and actually, sorry, typically, no, you should always put the element that wants to gain electrons, put that one last, okay? So let's put calcium and sulfur together. Calcium wants to lose 2 electrons, sulfur wants to gain 2 electrons. So what would the crossover rule predict here? Okay, so in this case, we have the number 2 here. We have number 2 here. So if we exchange the numbers, we get this formula. All right. Now, what we can do in this case is because the number is the same, we can actually reduce this to just CaS, and this would be called calcium sulfide. Okay, easy stuff, very easy. Let's do one more example. Let's take a look at aluminum. Okay, so we'll put aluminum over here. And aluminum is would like to be +3, and oxygen would like to be 2 negative. So again, if we put them together, we use the crossover rule. So again, this 2 will go here, this 3 will go here. So then this would be called aluminum oxide. So the formula would be Al2O3. Again, we flip the numbers, and this would be aluminum oxide. Perfect. Okay, let's stop there.